let's start with a simple problem. Let's go old school. All I want to know is if I have Timmy on the top of a cliff, let's go 29 meters tall, and Timmy has a mass of 82 kilograms. What is the velocity right as Timmy hits the ground? Okay? Velocity as Timmy hits the ground. Starting recording. What is Timmy's velocity at impact?
I might just see what everybody else is doing so I can double check that my work is correct.
That's one way to do it. Okay, so here we go. Super simple part. You know at the top. Do we have anything other than potential energy? No. At the bottom we have all kinetic energy. Those formulas, mgh, mass times gravity times height, equals 1/2 mv squared. You plug in what you know. You get to there, do the math. We've got velocity of what? Who's going to volunteer their answer? What you got? 23.85 meters per second. We know that's not terminal velocity, correct? Terminal velocity does not mean you're going to die, it just means it's going to hurt a lot. Yes? Questions on this one? What do we got? Nothing so far.
Anybody ever jumped from a really high area?
Without a parachute?
I've actually done a jump similar to this, and I would not recommend everybody.
Cliff diving's fun. It stings a little.
29 isn't that high. Yeah, I've done 40. Yeah, it was.
Hold on, 29 meters is a
Oh, I guess. Yeah. Meters.
times 3. You're looking at 90 feet, which is technically 9 floors. It sting a little.
It didn't feel good.
All right, I'm gonna give you a little harder. Hey, a little harder, yes? Just a little.
More power to you guys.
Let's do 127 meters, yes? I'm still looking for the velocity. Instead of Timmy, we have Tommy. Find the velocity. Find the velocity. Don't know how much Tommy weighs. See how far you can get. It can be solved without the mass. Okay, many of you got here, yes? Potential energy equals kinetic energy. Then you went mgh equals 1/2 mv squared. And all of you algebra people said, oh, this is so simple. All of you non-algebra people said, I got nothing. I'm stuck. If mass is on the left and mass is on the right, what can you do with mass? You are stuck with 9.81 times the height of 127 meters equals 0.5 times velocity squared. Here's the question. You got two possible answers, 49.9 or 24.96. Okay. Did anyone get 24.9? Good. Oh. Close. You did one small algebra mistake. No, you're good. Hey, listen. Look, everybody look at the screen. This is the most common mistake on this problem, because you'll see this again. 98, or 9.8, the calculator would work with me, 9.81 times 127 equals 1245.87 equals 0.5 v squared, yes? What do we have to do with the 0.5? Divide by both sides by 0.5. If you divide by 0.5 and then take the square root, you should get 49.9. That is the correct mathematical way to do that. If somehow you say, I'm going to multiply by 0.5 because you done broke math, you get this answer, which is wrong. It is the most common mistake on this problem. So remember, if it's attached by multiplication, to get rid of the attachment multiplication, you have to divide. So your answer should be 49.9. Yes? Cool. Let's do one more. $186 meters tall. I'll give you a mass of, let's do 10 kilograms. You throw a ball up with a velocity of 13 meters per second. What is the velocity at impact? Now many of you are panicking. Please don't panic. Think through the problem, draw out the rest of your diagram. You can solve this. You really can. And you do not have to refer back to any other chapter. Hello. Okay, let's talk common sense. Why do we not shoot bullets up? They come back down at the same speed, yes? So let's take a look at our diagram. We went positive 13 meters per second, yes? So at that same point, when it comes back down, what is the velocity? Negative 13 meters per second, or going downward. Yes? So now we have a velocity and a potential energy. This is VI. I want to know the VI at impact. I'll give you a hint. There's your hint. Take a look at your notes. All right, hint 2. What does ME stand for? Mechanical energy, initial, right? So I have potential energy, initial. I have kinetic energy, initial. Add those two up. Mechanical energy, final. What is my only mechanical energy at impact? Kinetic. Away you go. All right, so here we go. Fill it in. Your potential energy comes 82,246 plus 845, 5v squared. Do the math. Hopefully you get a velocity of 61.8 meters per second. Questions, comments, concerns? Little concerns? Not so much yet? I would love to zoom out. Let me see if I can zoom out a little bit. Nope, I can't. Questions? For those of you tuning in, please send email questions to ericmaybe@pipeschools.us. Sarcasm intended. Hearing no questions from the viewers at home. Yes, sarcasm is the menu of the day. Let's take a wild stab and have some fun. We're gonna launch Jace up a hill on a sled. We're gonna say the mass of Jace and a sled is 200 kilograms. The angle, let's go with a slight angle. It's just a small hill. Let's set 17 degrees. Jace knows his sports, so he's going to say the coefficient of friction, he's made this sled super slick, is going to be 0.08. And since he is crazy, his initial velocity is 1 million. He never ends. Let's go 18 meters per second. By the way, that's really fast. You can do the math. All right. So what I want to know on this question, and I'm going to leave the viewers to find on their own, I want to know the distance. We'll start this problem next class. You will solve it. You can send me an email asking what the answer is, but for now, we're done for today on this one.